Yeah.
Very nice to see you again. Oh my goodness, it's been a really long time.
It's been a very, very long time, Mishi. So nice to see you.
Yes, yes. Thank you. Thank you very much for joining. I really appreciate this. So let's get started. Hello, everyone. Welcome to this discussion, this fireside chat on industrial AI with Dr. Chetan Gupta. Dr. Gupta is VP and Chief Data Scientist and Architect, and is the head of Industrial AI Lab at Hitachi America R&D. He has more than 15 years of experience in analytics, AI, big data, and related domains. Over his career, he has worked both as a machine learning data scientist as well as in designing systems and architectures for big data applications. We can go on about his bio and his resume, but
Yes.
let's
Yes,
take some
please.
time to talk about really,
Yes.
really insightful things today. Uh, Thanks again for joining us, Chetan. I really appreciate it.
I'm very happy to be able to do this, Mishi. Thank you for having me over.
Of course, of course. So let's start. Let's talk a bit about industrial AI, and we're just gonna keep this very informal and conversational. And for anyone that's in the audience, if you have any questions, please put them in the chat, and we'll address them as we go along. Right. So, Chetan, how would you define industrial AI in particular? Like, it's different from regular AI,
Yeah.
and how is it different from regular AI and the other use cases?
Right. So I think AI is AI, right? But sort of, so that the basic math doesn't change. But I think industrial AI is the way I define it is use of AI machine learning techniques to solve problems in the industrial or societal domains.
Right.
Now, once you sort of think from an application perspective, it brings its own set of unique problems, challenges, and opportunities. And that's what I think sets it aside from what I call more traditional uses of AI. Although AI is still very young in many ways, but there are areas where AI is quite more entrenched. People think of AI sort of as being a first class citizen, but industrial world is where we're still sort of starting out. So industrial societal world. And I think that's where a lot of fun is, a lot of opportunity is.
Right. Makes sense. Absolutely. And so, what would you say some of the examples of industrial, in particular AI, are in terms of whether the use cases or the applications?
So there are the way I think about industrial AI is sort of in terms of horizontals and verticals. So so if you think about so actually let me elaborate a bit more on industrial AI, right? So people have done AI now within the enterprise context for say HR or for
Mhm.
marketing for sales, but the operations where uh, uh, we operate in the physical world,
Right.
right? So that's where the industrial AI comes in. And if you think about the horizontals, right? And so maintenance comes in, right? You want to maintain your equipment, your processes, quality comes in, operations optimization comes in, safety comes in, automation comes in. So these are horizontals. And our thesis from the very beginning, I started this lab, I don't know, maybe 5, 6 years ago, was that there is a commonality across verticals, right? So 5, 6, 7 years ago, people said, oh, there's no common AI, so to speak, right? If you want to solve a problem in manufacturing of auto parts, it's different from say solving a problem in mining.
Mhm.
But as we have sort of studied this problem, what we have realized is there is a set of common problems, and those belong to the horizontals that I mentioned, like maintenance, repair. So to give an example, very many years ago we did with optimization for mining. So what happens in open pit mine? So for people who are not industrial, right? No one really knows what happens in the physical world anymore. So you have the a rock surface where you blast,
Mhm.
and then these very large shovels, they pick up either ore, if it is ore, or if it is rock, then it is needs to go to a dump, and you put it in this very very large trucks. So if you're seeing a mining truck, it is as tall as a 3 to 4 story building,
Right.
right? And so optimizing the route is very important. So two kinds of problems can happen. For example, one is called shovel starvation, meaning shovel is ready to pick up something and dump into a truck, but there's no truck around. So essentially, you're wasting the time of the shovel. And queuing. So queuing, everyone understands, right? So trucks are piled one behind the other, and as a result, they're not being productive, right? So we solved this problem how to schedule trucks in a very very large mine site, so that you can avoid these two problems. I think a year or so later, we were talking to folks in Brazil, and in Brazil, one of the big industries is agriculture, especially sugarcane, right? And once you harvest the sugarcane, you have to take the plant to a processing plant, like the sugarcane plant to a physical processing plant, right? Within 24 hours. Otherwise, the quality of sugar that you can obtain is not as good. Now, it turns out this is very similar to the mining problem. If you abstract it mathematically, right? The problem is essentially the math is the same, right? The application is different, the vertical is different, the nuances will be different, but the fundamental math remains the same. So this was the realization that sort of undergrids our thinking of industrial AI. So if we can identify these common problems and solve them, then instead of going vertical by vertical, one problem at a one problem, you're able to attack a larger space. And so you said what are some of the examples? I gave you one example, right? So examples like this abound, right? So same think about for example, there is a notion of using now reinforcement learning for scheduling, like
Mhm.
we did mining scheduling. Similarly, if you remember your operations research, the scheduling needs to happen in manufacturing as well, right? And the scheduling needs to happen in data centers as well.
Mhm.
Right? So this is the sort of commonality you begin to see. So think of AI and the problem that the set of horizontals where we can um, attack.
Right. That makes sense. And this is really not something that's unique to industrial AI from the sense, more in terms of the application of AI in any given problem in general.
Um,
You can find,
can you elaborate on that, Mishi? Sorry, I didn't understand that point clearly.
no, so I was agreeing with you that this is something that's really true, not just for industrial AI, but for AI in general and applications and data problems.
Yeah,
Usually, as a data professional, you solve one problem in one vertical, one field, and you go to solve in another field, and you find they're very common. Now, the subject matter expertise around them are vastly different. They're at different domains, but the sort of way you approach the problem and the way you solve it, underlying the mathematics
yeah,
and algorithms are really the same.
yeah, yeah, exactly, Mishi. Right. So we have the same roots in the same department, so that makes sense. But I completely agree with you in that regard, and I think that's the beauty of it. And for us, that was the joy of discovering the set of common problems. And as you know, we are researchers, right? We like to abstract things,
Yes,
right? And so that is the nice part.
fantastic.
Yeah.
That's really good. So I understand that some of the key challenges around industrial AI center around it being considered too academic, right? More R&D or unreliable, or being viewed as a technology that will require too many infrastructure changes, or too drastic a culture shift within an organization that's existed for 100 years, doing everything by hand and Excel sheets. Do you agree with this assessment?
No, obviously I don't. Otherwise, I won't be working in the field. uh, but I think some of it is true. I would say industrial AI is not academic. I think that's one of the challenges, meaning that a lot of the academic literature, if you go to conferences, AI conferences, is around very algorithmic sort of, and around certain kinds of data, which although they do occur in our industrial domain, but it's only a sort of fraction, I would say, of
Mhm.
the data types that we have to deal with. So on that regard, I would say it is not necessarily academic, but it is still in some sense in research labs or in sort of sometimes there's a lot of, as you would call, proof of concept, proof of value that you have to prove. So that is certainly a mindset change that needs to happen, and it's not unreliable per se. It is much more that in industrial setting, right? So sometimes accuracy is not the same as correctness,
Right.
right? Right. So meaning, and one other way to think about it is the cost of failure, cost of making a mistake, sorry, in industrial setting is much higher than otherwise,
Mhm.
right? So suppose I have to recommend something to you, say a piece of music, an article of clothing, and I have a ranking, right, 1 to 5.
Mhm.
Now maybe if the ordering is a bit different, you will still get what you want to some extent, maybe not the most ideal, but in the case of industrial AI, sometimes there is only a binary answer, right or wrong, a yes or no. And that's where some of the challenges arise. So it's not necessarily unreliable. In fact, AI itself, as we know, is sort of unreliable, right?
Mhm.
So the challenge for us in the industrial AI community is to be able to use that AI in the industrial setting, given the fact that AI sometimes is unreliable. right? And in terms of infrastructure changes, I think those are happening anyways. So most corporations are investing in data collection mechanisms, and they have to if they need to sort of be competitive, right? So that is happening, and obviously uh, there is sort of a spectrum, right? There are some industries, some corporations that are quite advanced, and there's some industries and some corporations that are quite behind. And you see the whole spectrum as you talk to customers and talk to people. They're all over the space. And in terms of cultural shift, I think that's actually a very nice question. And by the way, Michelle, that's a very well framed question. I think cultural shift is happening, but it is one of them. In fact, humans are always the most difficult, right? Machines is okay. So right, so that is a challenge. But to my surprise, in very many corporations, there are people who are thinking ahead, who are thinking as to how we can use the latest technologies to make things better within the corporation and in the outside world. And if you can get partners like that, it can make a whole lot of a difference. So, so I would say that there are, like, whenever there is a cultural shift, there are people who are in the vanguard, right? So they are the ones leading the charge, and there are folks who sort of are followers, and then people are like us, right? So so I think one of the and we have seen less of it, right? So when I first started out, there was more resistance, I would say, right? People were not really sure what AI means, what industrial AI means. But now we are finding more champions in the space. And as a result, the cultural shift that is needed is happening internally. And actually very fascinating to see because, for example, you're working with one of the largest fleet companies in the world. And so some of their maintenance leaders, who you would assume might be sort of very old school, are really trying to embrace and see how they can sort of make a change that can happen, right? So there are things like that that sort of, in some sense, very exciting to witness. Um, and in terms of investment, I think if you confuse IoT with AI, then yes. But AI by itself, in terms of investment, is not that much, right? And so if you decouple, in some sense, from IoT from I would say the investment is not really a challenge. I think if you think from that perspective, the challenge primarily is the existing data infrastructure,
Mhm.
existing data collection, and then there are a bunch of technical challenges that are sort of we need to solve. So that's where we are in some sense. But yeah. Um, uh, I mean, if you want to talk about challenges, I can go whole. I think something maybe we have time. We can touch upon that.
Yes, absolutely. Yes.
Yeah. Okay.
I was
So
like, go ahead. Yes, I was actually going to push on the point that you just made in terms of there's some sort of a distinction when in industry we're talking about physical assets versus the digital assets, right? And
yeah.
with physical assets, if you're doing this sort of shift into more automation and AI, there is just is beyond the infrastructure for the databases and the data storage and the processing of it. There's actually some sort of changes that needs to happen to monitor and collect that data itself. Is that part of the reason that makes things a bit difficult, or that part of where the challenge lies?
Um, I think in terms of the physical infrastructure, it's not as much a technology challenge. I mean, there are some technology challenges, and I will come right to that. But I think what you're alluding to is, in some sense, the investment challenge. I think we know how to, for example, store time series data or event data. We know how to process that kind of data, right? I think uh, maybe maybe what you're alluding to is the fact that we need to prove that there is an ROI at the end of it. And once you can say, look, if you invest X amount of dollars and the return is X plus Y, and that's why it makes sense for you to invest the X, then I think the discussion becomes easy. Now, obviously, there are sort of challenges in terms of. I mean, if you think about challenges, I would like to sort of put challenges in three categories: data, um, modeling, and say operationalization, right? So in terms of data, I mean, as you can imagine, typically in industrial processes, we haven't instrumented them to collect data for the sake of AI machine learning, right? Most of the instrumentation is for the purpose of say safety or some sort of regulatory requirements, right? So the data can often be missing. And even when you collect data, there's sort of bunch of noisy data, because if you're collecting data out in the field, then there is always data integrity and data quality issues,
Right.
right? From a modeling perspective, I think one of the bigger challenges that if you were to sort of do industrial AI is that we have to build models over heterogeneous data. So to give you an example, for example, if you want to diagnose, say you go to a doctor, right? You go to a doctor and you want to get a prescription for something. So the doctor has various, right? So he or she will look at you, will talk to you, right? Will try to understand what your symptoms are, the way you describe them. Then he or she might take some measurements, your temperature, whatever, right? And now you need to build a model over this, right? So you need the multimodality becomes sort of first class citizen. So in machine learning, we have made a lot of progress in deep learning with models, say for images or for language, but we are dealing in a different world where you have multimodal data. On top of that, the data that you might get is not always very large, right? So I have, say, a pump running somewhere. It is emitting some data, but there is one pump or two pumps or three pumps. It's not that billions of people are saying something, right? So that's the other challenge, right? So very often big data is not so big for us, right? So we have to work with small data, try to make it work. Another challenge is purely from modeling perspective, and I think you will appreciate this, is that you're really trying to model very complex systems. If you think about an automotive, right, a car, for example. So you think about it is a system of systems, right? So there is a high pressure pump, there is an engine. High pressure pump has own components, right? And any small thing can fail. So how do you model such a complex system which is made of so many subcomponents? And within AI machine learning, we haven't really thought of these questions in, very systematically. Another challenge that we see sometimes is incorporating domain knowledge.
Mhm.
So, for example, I'll tell you the story, right? So, my very first job was in a chemical plant, and there was this guy. He used to carry a steel pipe, a very small, thin steel pipe, and he would hit all the water pipes and gas pipes, and he would listen to them. And based on the sound, he could tell whether there was something wrong with it or not.
Oh, wow.
These guys are very, very good at what they do, and they have a lot of institutional knowledge. They have a lot of domain knowledge, right? Now, if I want to do something similar with AI, how do I incorporate that this gentleman's domain knowledge, right? So there is a technician who has been fixing, say, air conditioners for 50 years, right? He could fix it with his eyes closed. How do I learn from him as an AI system? How can I replicate his knowledge? So these are some of the challenges from a purely modeling perspective. And then I would say the third category of challenges is around operationalization. So tell you another story, right? So suppose you have a failure prediction algorithm, and you love it. It's a beautiful algorithm. Now you use it on a flight. Okay. Now the flight is in the air. The algorithm says say there is a 1% chance of failure. What would you do, right? And if the same algorithm, remember, like if you remember my car, it's a dinky old car, right? In grad school, if it said, there's 1% chance of fail, I knew that, right? It was, it is definitely going to fail, right? So the decision, the action that I would take in these two cases will be drastically different. So what I really need to understand is I need to layer a layer of decision making
Mhm.
on top of my prediction. And that's another area where AI machine learning is still sort of has ways to go. We have done well at prediction, but how to make a decision, how to do these cost trade-offs, how to model cost, how to really understand this is actually a very, very, very difficult problem. And and very often you have to make decisions under uncertainty, right? So for example, your model might say, I'm 80% sure that your equipment will fail in the next 5 days.
Mhm.
And then next day it will say, I'm 75% sure it will fail in the next 4 days, right? So now how do you operationalize this, right? How do you automate a system like this? uh, and yeah, and the fact is that real world is sort of is analog, right? It's not really digital, and you're trying to measure it from a digital perspective and then trying to model it. So all these are sort of very, I would say, fascinating challenges in the space. I'm sort of become a preacher in this space, right? So I want more people to join the gang who does industrial AI. But I think the set of problems that we are facing are really very interesting and hard.
Yeah. I could not agree more. I was going to save this question for later, but since it sort of came up, I think it's important that we talk into it right now. So we talked about trust, right? The percentage. How do you? It's probabilities. It's all about probabilities. We live in a world of probabilities. Is that? What would you say about the importance of trust, reliability, and security, right? Especially as it pertains to industrial AI in
That's actually a very good question, I think. Um, so I would say that reliability, security, explainability are
Mhm,
all part of making a trustworthy system, right? So think again, right? I always put myself in the shoes of an operations guy, right? A person who's actually running, doing something physical in the world, right? So they want to have a system that they understand
mhm,
because it is unlikely that they will fully trust something that they don't completely understand. Right? So explainability is important. I think people appreciate that. But I think you raised two other interesting points about reliability and security, right? So obviously, if I'm going to rely on a system, if I'm going to use a system day in day out, it has to be reliable. And I think in this, I want to sort of bring up very interesting problem, which I want to sort of open for your audience if they want to solve it. Right? So this is the problem of what we call reproducibility, and we wrote a NIPS paper, I think last year. And the problem is this: you build a machine learning model, you deploy it in the field, right? You deploy it in the field, and as we know, we sort of retrain it every month or whatever, right? Every week, whatever your periodicity is, you're going to retrain the model. It turns out that every time you retrain the model, because it's sort of pretty sophisticated deep learning model, it reaches a different local minima.
mhm,
Now, it's the same example will have a different outcome from between one version of the model to the other. Now, if you have an intelligent user, he or she might say, look, last time I had this query, I got the answer X, right? And this time I'm getting X prime. What is happening, right?
right.
So this question of reproducibility and as I said, reliability, right? So reliability has other aspects to it, right? So I want my system to be responsive, meaning that if I want my system to be responsive in terms of response times, in terms of being able to give the right answer, right? So these questions really make for a trustworthy system. And security is another challenge where I think in the industrial setting we're still learning about it because the number of systems that are deployed in critical infrastructure running on AI are still very few. For example, I always joke about it, maybe, and it's a joke, right? I don't want to use AI in a nuclear power plant, right? I don't- Not today, at least, right? Uh, but security for us is an interesting point, right? So for example, as humans become more reliant on these AI-based systems for recommendation, right? So for example, we're building a solution where uh, if you back to the doctor example that I gave earlier, right? Equivalent to that could be you take an equipment, you say you take your washer or your whatever equipment you can think about for repair. And so one of the challenges in repair is a diagnosis, right? Really to pinpoint what the problem is. So you make a recommendation engine that does diagnosis. Now, can I attack it, right? So can I give it? We have tried to do that internally. We have tried to build a system such that we we are able to produce erroneous recommendations.
Mhm,
Now, suppose the system has been in place for several years and humans have sort of begin to trust it blindly. And now it is attacked in this way. It can lead to significant sort of losses and sort of severe poor outcomes. So security is very important. So my feeling is that um, the the notion of trustworthiness includes all of this and maybe a lot more. And in the industrial setting, this questions become much more important because mistakes are very expensive, not only in terms of cost but in terms of lives as well, right?
mhm,
So industrial setting, right? So we have to make sure that we keep uh, our workers safe, we keep our partners safe, right? So to me, I'm very careful um, in when AI systems can be used? When can they be relied? Can I trust them? And especially, we're not at a point where the systems are completely automated,
Mhm.
and that is part of the reason, right? So, meaning we don't have systems that we can 100% trust to work in a completely automated fashion. So that's why very often the AI systems that you will see have a human in the loop. So I will use an AI system to make a recommendation that human can sort of at least check,
Right.
and then sort of use it. So that's where a lot of AI is today. I'm not right. So yeah,
No, that's a really great response to that. And the discussion is going so well. I'm like taking away from what I've planned in terms of her target. But I'm going to ask one more that's a bit out of
yeah.
field. So, with something like events that happen, right? Unforeseen events, how does it affect the AI system, and how does that affect operations within industrial settings? Take for example, the pandemic, right?
Mhm.
That's not something that any of the models could have predicted, and I'm sure it had an effect on most models or some model drift in some way. Sometimes all the models was basically it needed to be thrown out and recalibrated. Was that something that was experienced in your experience have affected industrial AI in any sort of way? And if so, what was the sort of solution to basically correct that?
That is a, you're not supposed to ask me such difficult questions, Mishi. Actually, that is actually a very very good question, and the reason I sort of laugh at it is because, like, just yesterday I was having a discussion with the team, and they're trying to build a model, and the first thing they did was they threw last year's data, and I asked them why. This is data impacted by pandemic. We can't trust it, right? It is, the behavior is very different from what we would otherwise see, and and this is exactly to your point, right? So last year has been difficult. So I would say two things have happened. So one is because of the need for people to work remotely. I will not give sort of standard answer, but the idea was that can you uh, so the decision aid systems in industrial using sort of industrial settings, so they became more important because then you could reduce the need for very many people to be co-located.
Right.
So we saw, in some sense, a better appreciation for some of the solutions that this field could bring. Similarly, we saw an interest in trying to redesign supply chains because they were very severely impacted, right? So now folks want to design supply chains which are more resilient, right? So which can sort of, as you said, right, if these unforeseen events happens, how do you respond to that? So can you make your supply chains much more flexible, resilient, and so forth? So that is the good part, right? So where because of the changes that pandemic caused, we had society had to adjust, industries had to adjust, right? And that sort of in some sense increased the appreciation for some of the solutions that we're bringing to market. But at the same time, to your point earlier, it also poses a challenge, right? So now the distributions have shifted in this pandemic, right? And so I think what we saw was um, at least most of our models were robust enough, I would say, that they were able to handle very many changes. In some cases, there was certainly this notion that we need more human intervention because this distribution has changed. But we didn't see too much of that. But I can clearly uh, appreciate where you're coming from for that. So, so I think yeah. So there were sort of two aspects aspects of. One was on the positive side. I mean, there was nothing positive about the pandemic, right? This is sort of
Yeah.
it's been a worldwide tragedy. But yeah, it's like be careful. But uh, purely from a sort of a industrial AI perspective or movement towards adoption of more modern ways of doing operating industries. So there was a shift, but the challenges remain. And I think the one that you point out, I think she is actually a very uh, we can we need to think more systematically about that because things like this will happen,
Mhm.
and there will be a different distribution shift first because of something else. And how does AI, which is so reliant on historical data and not first principles, how does it respond to systems like to situations like that? I think is a very, very good question. I really like that question, I think. Thank you.
All right, so that means we're all going to put our heads together, and hopefully, some researchers are going to come up with better solutions in terms of this is sort of a framework for a strategic framework for handling black swan events like that
Yeah.
in the
Yeah.
models. All right, very good. Now let's shift the focus a little bit away from challenges to solutions and opportunities, right?
Mhm.
Where do you see the biggest opportunities existing in industrial space today?
I think opportunities abound. I think this field um, will fundamentally change the world we live in. And I'm very confident of that. Right. And we are beginning to see it. We're beginning to see where corporations that are embracing the use of data are beginning to get a leg up. And it's not that they're beginning to get a leg up. It's just not that. It is that we are changing the way systems are run, right? So in industrial setting, change happens when process changes, right? What we're beginning to see is the processes are changing,
Mhm,
right? And as a result, the way you and I or people who are operating these systems, that is changing. And the net outcome of this is the systems are becoming more efficient,
mhm,
and they're becoming more reliable, right? So the opportunities, in some sense, are across verticals. To so back to like the horizontals we talked about, right? Maintenance, operations, quality. So there are fundamental problems in each of these, right? So for example, very often when people think about industrial AI, the first thing they talk about is prognostics, right? Can I predict failures, equipment failure, process failures? And even that is not one problem. Right? So that itself, for example, is a huge set of problems. To give you an example, right? You might have fewer failure examples in one case, or or if you we might have a very large number of failure examples, right? So your modeling will change with that, purely from machine learning perspective, right? How much data do you have, and what kind of data do you have? Sometimes we have sensor data,
mhm,
but very often we have event data. For example, if you're modeling a car or a truck, so if you ever gone to a mechanic for your car, they insert an OBD dongle at the bottom of the vehicle and they pull what are called fault codes.
mhm,
So this is how a vehicle communicates what's wrong with it is through fault codes. So maybe in this case you need a model that runs on fault codes, not on sensor data. Or if you want to look at surface defect detection, right? So the image data is the input. So um, so even right. So the different types of data, and whether you have enough failure examples or not, and whether you need an explainable model or not, right? And and how much footprint can you use to run the model in the field?
mhm,
So even for a very simple problem, you say, oh, prognostics, failure prediction. There's so many sub solutions that you need to think about. So that's where the opportunity, right? Really understand, right? So this is a broad problem, and what are some of the use cases, and how do they derive the requirements for the algorithm that you want to develop, that it can actually be useful in the field. It's easy to write papers, but more difficult to sort of do stuff in the field, right? So this is just one problem, but there are what we had done in our lab was we looked at the horizontals of maintenance, quality, operations, supply chain, and then looked at it from a perspective of predictive, prescriptive, and descriptive, so to speak. And we identified 50, 60 odd problems. And these are problems, for example, and if you think about maintenance, it is I said, for example, failure prediction. A
yeah,
sister problem is remaining useful life estimation. This just tell you the nuance, right? So remaining useful life will tell you how much life is left in my equipment. Failure prediction will tell you whether my equipment will fail in the next 10 years or not. So one is sort of can be modeled as a classification problem back
mhm,
to our machine learning language. The other is to be followed as a regression problem.
mhm,
Right? And the other problem in maintenance is, for example, you remember when I was in grad school, the car, you're taking oil change for every 2,000 miles. It
yeah,
turns out that you really don't need to change your oil every 2,000 miles, right? But if you had been able to evaluate the performance of the car before and after maintenance, and what you could do is do maintenance effectiveness estimation, right? Whether this maintenance activity is effective or not, or is it is useless. People
mhm,
don't do that today, right? So that's another problem, right? Another problem in maintenance is when I take an equipment for repair, what is the right repair to do? What is the least cost repair to do,
mhm,
right? And so these are some set of problems in, say, maintenance. In quality, there are a set of problems around, say, for example, operating envelope, right? So I have to do certain tasks. Can you define an operating envelope such that the number of failures is minimized,
Mhm.
right? And then can you predict whether, based on early testing data, can you predict whether a part is going to fail later in the stage, right? If you think about assembly line, so there are
Mhm.
different steps that you need to do with the part. And
Mhm.
very often what happens is the part fails at the very, very end, right? So in the last test, the part will fail. Now, so all the effort that went into getting to the last point is wasted essentially from a purely industrial perspective, right? So if you had been able to detect this early on, then you would have been able to save that much resources, right? So
Right.
then can you predict earlier in time whether a part is going to fail or not? Can I create, as I said, an operating envelope to minimize my failure? Can I do make a recommendation like that? If you think about operations, right? We talked about the scheduling problem in mining or manufacturing, right? And there are problems around operators, right? So can I categorize the performance of an operator given a task, right? So for example, you're brilliant at math, and I was not brilliant at anything, right? You could characterize that, right? Okay, so math, Mishi, Chetan, good at nothing, right?
Mhm.
So stuff like that, right? So there are, I would say, um, very, very many problems in each of these domains that you can solve. And I think that's where the opportunity is at a point problem level in industrial AI.
All right. No, you have convinced us about the many, many problems and opportunities that exist, that's for sure. Let's talk a bit about the new trends, right? The more emerging tech. So if we're talking about industrial AI, which we are, we must talk about IoT in some sense, right? It's
Yeah.
almost more de jour in these days. And so we're talking about IoT, we're talking about digital twins, we're talking about edge computing. Those are all like technology uh, advancements that are being done, especially relevant to industrial AI. Why do these technologies matter?
So IoT matters because you need to collect data from your sensors and equipment, right? And I think very many corporations are at that level, institutions at that level. They're just collecting data and we're building dashboards, trying to empower the humans to really understand what's going on in the operations that they're monitoring or that they're running. So that's where IoT is important. I would say AI is obviously a step further, right? So AI is not just how do you sort of get derive insights from the data, uh, that are beyond visualization. And the other thing I want to say is people often confuse uh, AI with IoT. What I mean by that is when you're doing industrial AI, you don't always need IoT data. So
Mhm.
back to the scheduling problem, for example, right? The scheduling problem, say in a mining site or in manufacturing, that might not require as much IoT data. It's a traditional problem, right? Scheduling is an old age-old problem, and the reason I sort of incorporate industrial AI is because now you can use different kinds of reinforcement learning techniques to sort of address that.
Mhm.
So so IoT data, I would say, plays an important role in industrial AI, but it's not the only type of data that you need to collect to really be able to optimize your processes. Next thing you said, digital twin, right? Digital twin is sort of, I would say, a narrow digital twin in sort of different people have different definitions of it, but
Mhm.
generally speaking what people want to do is they want to create uh, digital replicas of the physical equipment.
That's right.
And so the idea is you could collect the data about them, you could model them, you could create a schema, you can query that data. But AI again, sort of, the question is how much AI you overlap on top of the digital sort of avatar of the equipment, right? So can you do failure prediction over that, or you want to sort of do an operating envelope over that, right? So that becomes sort of next layer, I would say, from a purely digital twin perspective. And I think the third thing you said was edge. So edge is in some from a deployment perspective, right? Sometimes a model runs needs to run on the edge, sometimes the model needs to run on the cloud, or sometimes you have a hybrid solution, and that poses its own challenges, right? So sometimes even the training of the model needs to be done on the edge, right? You might not have the luxury to sort of ship the data from the edge to a cloud, build a model, and then ship the model back down, right? So sometimes you don't have to do that. Sometimes you cannot do that, right? Sometimes you have to sort of build a model at the edge itself, right? Or you have to build sort of federated model. You might have data that is in different edge nodes, but you can't really bring them together, right? So how do you build a model where you have different data sets distributed at different edge devices? So I would say these are all complementary technologies. Uh, in some sense, industrial AI sort of is a layer on top of this, right? These are much more the current set of problems that we are sort of dealing. Industrial AI is the next sort of avatar, next version of these problems. There's these areas, so to speak. Yeah.
No, that's fair. Are you aware of, or are there really any regulations in industry that would maybe deter a company or a client from taking advantage of industrial AI technology?
I mean, industries are pretty heavily regulated, right? So we have to be compliant in terms of safety requirements. Maybe if it's a union shop, then you have to sort of take that into account. So there are always challenges around regulations, but yeah, and you have to design solutions that work with that. Sometimes regulations cause us to build new solutions. For example, if there's a safety requirement, then you might want to sort of do that using AI and stuff, right? So like, and especially for industrial settings, safety is important.
Mhm.
And so and depending on which industry you are in, you're always in some sort of regulatory environment, and so you have to sort of adhere to that. We have less of a, I would say, challenge around privacy and so on and so forth, because we don't use as much of human data.
Right.
So that is the easier part. I've always joked, right? It's so much easier to work with machines than with humans, right?
True.
So yeah, right. So you don't have to sort of, that's another reason of doing industrial AI, right? You don't have to worry about
Right.
hurting people's feeling, right? So
Yes. No, that was very good. Thank you so much, Jason. To rapid final, what are your final thoughts in terms of what directions you see industrial AI moving, say, next 5 years from now, 10 years from now?
I would say in the 5 to 10 years window, you will see much more rapid adoption.
Okay.
And another big change you will see, which I think will be very transformative, is we'll begin to model and optimize larger and larger systems.
Hmm.
So think about again, right? So today we say we might want to model one machine or two machines. Tomorrow we'll model an assembly line. The day after we'll model a factory, and
Right.
the day after we'll model multiple systems working together. So to give you an example, right? For example, you're manufacturing something, and near where you manufacture, there's an energy plant, renewable energy plant that relies on wind energy.
Hmm.
Now, if you could predict with confidence, say, amount of energy produced in the future from the wind plant, then you could sort of have some sort of digital contract with the manufacturing plant so that they could get cheap energy, and then you don't have to sort of as a unit generating wind power, you don't have to worry about storing it, you don't have to wasting it, right? You can get maximum use of your energy, right? So what you will see, Mishi, essentially is that as society will try to optimize for larger and larger systems, right? And I think that is a future. That is what is exciting, and that's what will bring a real transformation. I think my feeling is maybe 15 years down the line, AI will become much more sort of central to the way the world operates and runs. And a lot of it would have come from today's talk. Just-
I can hear it. I see that. I think that's entirely feasible. But we'll see. We'll see what happens. And hopefully it does so too, right? If all the if everything gets automated in that sort of manner, life becomes easier for the organizations, for the employees, for their communities at large.
exactly.
So everyone wins really.
Yeah, and I think there's a lot of good that can come from it, right? For example, now we are building solutions, for example, to do enable agriculture in places where there was no agriculture. We're trying to energy saving is a very big thing for us,
Mhm.
right? So trying to make systems more efficient. So you will enable newer solutions that are much more, I would say, environmentally friendly. Um, yeah. So, for example, I'll give you another example. In mining, you have these very large trucks,
Mhm.
and you have very large trucks because they need to be human operated. Now, if you could replace them with automated trucks, you could replace the large trucks with smaller trucks, and that would save energy, right? So not So the downstream effects of AI will be for the positive in that regard. Is my mind is where my head is.
Right. Well spoken. Well spoken. So I think we're at time. Thank you so much, Dr. Gupta. This has been
Thank you.
fun. We need to have more conversations like this, I think, on
Yeah.
the regular. It's been very enjoyable for me, and I'm sure for the rest of the viewers as well.
Thank you, Mishi.
All
Thank you
right.
for having me.
Of course, it's our pleasure. Well, thank you, everyone. I think the next session starts at 3:45, and we'll be able to talk about high performance data analytics as well as delivering value with data science, AI, and ML. Until then, I will see you later. Bye.